So, we all listen to music, right? I mean, I would think you do. Maybe some people don't like it. I don't know if I've ever met anyone that didn't like music of some sort. We may not all be musicians, but most people like music. Did you realize that music is based on math? I'm ruining music for you, aren't I? No. So we turn our attention to performance art, like music. For centuries, music has been a medium that has allowed man to express the breadth of the human experience. Musical sound can evoke a wide range of emotions, whether it's created vocally, with stringed instruments such as a violin or a harp, with drums, or with any other instrument. Now, I played piano as a child. 13 years of it. I was actually supposed to be a piano teacher, and I went to Appalachian. Started out as a music major. After the first semester, I switched to math because I found math easier. Isn't that awful? Or at least less time consuming. Oh my gosh, if you're a music major, I applaud you. That was so time consuming. But some of the things in this section, I didn't even realize yet, even though I was a musician, and still am to a certain extent, I suppose. But I never really learned a whole lot about frequency. And frequency is math. The frequency of a sound, each sound has a frequency. And it's the number of energy wave cycles, sine curve, yeah, we won't even go there, completed in 1 second and is measured in hertz. Pitch is the tonal quality that is defined by how low or how high an instrument sounds to our ear. I was always very good at using music to play the piano, but I don't have the best ear. My dad, on the other hand, you can play a key on the piano keyboard and he can tell you what key it is. It's really amazing. A portion of a piano keyboard will give us a basis for how musical notes are represented. Little introduction to the piano here. The white keys represent the notes A, B, C, D, E, F, and G. These notes are repeated over the entire keyboard. To the left of any key, the pitch of the notes gets lower, and to the right, they get higher. A half step is the distance between one note and the next nearest note on a piano. Like from B to C is a half step. Or from C to C sharp, which is also D flat, is a half step. From E flat to E is a half step. A whole step is the interval between two half steps on a piano. So like a whole step would be from here to here, or from there to there. And an octave is the interval of notes between 12 half steps, or from A to A, or from C to C. Use the keyboard to help determine each of the following. What note is 1 half step up from G? So there's 2 G's on here. I'm just going to pick one. So we go G up to G sharp, or you could call it A flat. What note is 1 whole step down from G flat? So here's G flat. 1 whole step is 2 half steps, so 1, 2. It would be E. And what note is 1 octave from G? G. G to G is an octave. In an octave, the frequency of the highest note always has twice the frequency of the lowest note. So this G is twice the frequency of that G. So as you play C's up the piano, the frequency of the note is doubling each time. What is the frequency of A sub 1 given that A sub 3 has a frequency of 220 hertz? The 1 and the 3, that's just the position on the piano. So A would be the first, A sub 1 would be the first A on the piano. A sub 3 would be the third A on the piano. So if A sub 3 is 220 hertz, then A sub 2 would be 220 divided by 2 hertz, or 110 hertz. So A sub 1 would be 110 divided by 2 hertz, which is 55 hertz. The frequency of notes, any note on the piano, can be found by taking F naught, whichever one you're starting with, times 1.0593 or 9463 to the X, where X is the number of half steps up from F naught. And here's just a table showing you the frequency of several notes. I'm not going to go through that. You can look at it if you want to. Find the frequency of the note that's 5 half steps above A sub 4. And we'll use our formula F naught times 1.059463 to the X. A sub 4, if we look back at our table, is approximately 440 hertz. And it's 5 half steps, so X is 5. You put that in your calculator, make sure you do the exponent first, and then multiply by 440. Then that note would be 587 hertz. A chord is a set of 2 or more notes that produce one harmonious sound when played together. If it's doesn't sound pretty, then it's not really a chord. For a major chord, the notes are spaced such that there's 4 half steps between the first and second notes. So 1, 2, 3, 4. And 3 half steps between the second and third. 1, 2, 3. A minor chord has 3 half steps between the first and second. 1, 2, 3. And 4 between the second and third. It's just backwards. 1, 2, 3, 4. Use the keyboard to find the following chords. F sharp major. So we would start with F sharp. There's my kitty in the background making music. And we need to go 4 half steps. So 1, 2, 3, 4. That lands us on A sharp. And then 3 half steps. 1, 2, 3. Lands us on C sharp. So the F sharp major would be F sharp, A sharp, and C sharp. A minor, we start with A, and we go 3 half steps. 1, 2, 3. There's C. And then 4. 1, 2, 3, 4. and end on E. So A minor would be the notes A, C, and E. And last thing we'll look at is a perfect fifth. Consists of the top and bottom notes in either a major or minor chord. In other words, starting with one note and counting up 7 half steps. So 1, 2, 3, 4, 5, 6, 7. Completes a perfect fifth. And the notes in a perfect fifth have a ratio of 3 to 2. Show that the frequencies of the notes in the perfect fifth in Figure 6 have the ratio of 3 to 2. And the approximate frequency of D sharp is 311.127 hertz. And the frequency of A sharp is 466.164 hertz. And so if we take A sharp and divide by D sharp, that's 466.164 divided by 311.127, you get 1.498377. Do you see 1.49? That's very close to 1.5, which is 3 halves. And so that concludes our little section on math and music.